Welcome grade 11s to Learn Extra. This morning we're going to be doing measurements in 2D and 3D. I'm Hayley and I'm going to be taking you through all these exercises. So first let's look at our outline of what we're actually going to be doing. So I said we're going to be doing measurement in 2D and 3D. Pen. In 2D and 3D we're going to be looking at things like perimeter, area, surface area and volume, and that should take us through most of the section. Let us start with the units of measurement. Move that down a little bit. Right, so firstly we're going to be looking at perimeter. Perimeter is a value where you use one dimension. It does not change, it is always one dimension. And the units of measurement are normally your millimeter, centimeter, meter. You could even use kilometer, but most of our calculations will be done in those three measurements. Area, on the other hand, is always two-dimension. Area is always two-dimension, and your units of measure for area will then be millimeter squared, or centimeter squared, or meter squared, because we're dealing with two dimensions. Our volume, get rid of that, our volume is three-dimension. What is inside the shape? It is three dimensions. Oops. And we measure those in millimeter cubed or centimeter cubed, meter cubed, kilometer cubed, any kind of measurement, but it is cubed, three dimensions. Here, let's go through and do some simple calculations with just our simple shapes. Now, every question that you get, you can break down into simple shapes. They're going to be your square or triangle, rectangle, and circle. So let's start off by looking at our rectangle. A rectangle has got a length and it has got a breadth. I just want to stop for a second and look at a square. Let's try to find some more space here. And just look at a square for a moment. A square has got all four sides equal, but we can still consider this a length and that a breadth. So our square is a special type of rectangle where your length is equal to your breadth. But all the formulas that apply to the rectangle can be applied to the square. Right, let's go back up to this rectangle and look at what we're looking at. First of all, we've got our perimeter. Perimeter is if you imagine yourself on the edge of the shape. So let's imagine ourselves at this corner. Let's try it with a different color pen. Right, imagine we're on this corner and we're going to basically walk around the shape. We're going to go up the breadth, along the length, down this breadth, and along that length. That's going to give me the perimeter of the rectangle. Now, because the breadths are the same size and the lengths are the same size, we can actually, our formula, well, let's write our formula in two ways. Let's start with what I was doing. So I said, let's go with the breadth plus the length plus the breadth plus the length. But my breadths are the same size and my lengths are the same size. So my formula, I can actually take a 2 out of there because I've got two breadths, and I'm left with my length plus my breadth. And that's the formula. And remember, you will be given the formulas in an exam, so you don't have to stress about learning it. But the nice thing is you need to understand the formula. So let's try to do an example with the perimeter. So coming back to, let's look at an example. If my length was 8 meters and my breadth was 4 meters, how am I going to find the perimeter? My first step, I'm always going to write out my formula. So my perimeter was 2 times the length plus the breadth. And now let's substitute in the values. So my 2 stays, it's part of the formula. My length was 8 meters and my breadth is 4 meters. And now we can simply plug that into our calculator. So we've got 2, and let's open the bracket exactly the way it is. 8 plus 4, close the bracket, press equal, and we see that it is 24. So my answer to that was 24. And don't forget your units, they are crucial. So it's 24 what? It is 24 meters. Perimeter, one-dimensional, therefore just meters. Let's go back up and look at our area. So let's take these all away. And now we're looking at the area of the rectangle. So the area of the rectangle is length times breadth. So we're looking at the space in the middle. This is my area. It is 2-dimensional. So I want my length, the length times the breadth. Let's go do an example. Using the same calculations that we had earlier, with the length being 8 meters and the breadth being 4 meters, I'm going to write my area is now length times breadth. Substitute in my values. The length was 8 meters and my breadth was 4 meters. Do we need a calculator for that? Well, just in case, let's use it. 8 times 4 is 32. So 32 is my answer. And what are we dealing with? Area, 2-dimensional. So my units, which we can't forget, are meters squared. And in fact, if you go back to the question that we've substituted in, you can see that we've taken a meter and times it by meter. And that's why we've got meters squared. Let's move on to the next shape. Oh, now dealing with a triangle. Your triangle perimeter, again, we're going to just walk around the shape. So I'm going to start in this corner and I'm going to do, it's the base of the triangle plus this side plus that side. That is my perimeter. And then let's do an example. So let's look at a triangle where my base is 6 meters, the height of the shape is 4 meters, and the sides are 5 by 5. In fact, let's go back to the shape for a second and fill in all these details. So I've got my base was 6 meters. The height was 4 meters. And my sides were each 5 meters. Now, if you fill in the values that you're given onto the shape or redraw the shape in your books with the values, it makes it a whole lot easier for you to do the calculations. So let's go find some space where we can do this calculation. We're looking for the perimeter. The perimeter was the 3 sides. So what was the base? It was 6 meters. And we're adding the sides. The first side was 5 meters and the second side was 5 meters. Now, I'm not sure if we're going to need a calculator for this, but I think you should be able to do this in your heads. So 5 plus 5 is 10 plus 6. We've got 16. And what was the unit? Meters. Don't forget your units. Right, let's now look at the area of the triangle. I'm going to leave my values, just delete the perimeter. Right, the area is the space in the middle, 2-dimension. My formula for the triangle, for an area of a triangle, is half the base. Now we always look for the right angle triangle. So the base is one side of the right angle triangle. And then we've got our height, which is our perpendicular height to the base. So the formula, and now let's do a calculation for the area, is half the base times the height. Now we can substitute in our values. So my area was half, the base was 6 meters, and the height, that's the perpendicular height, was 4 meters. And then do this calculation. Let's get out our calculators. So on our calculators, we're going to use the fraction button because it is easier. So it is half times by the base times by the perpendicular height, and we get an answer of 12. And what are we looking at? Area, we've multiplied meters by meters, so it's 12 meters squared. I want a little bit more space now just to show you another triangle. So if you look at a triangle that looks like that. Right, if that's my triangle, I still have a base, but my perpendicular height in this case is actually not inside the triangle, it is outside, but it is still that height that we're going to be dealing with. Formula doesn't change, so let's just look at an example. If we had our base of, say, 4 centimeters in this case, and let's look at our height of 3 centimeters. So if we had to do this calculation, we're going to say it is half, the base is 4 centimeters. That's from that point to that point. Let's use a different color. Maybe we can see that. That's from that point to that point is 4 centimeters. And then we're going to times by the perpendicular height, which is that value there of 3 centimeters. And now again, we just substitute that into our calculator. So let's get our calculator out and use the fraction button. It is 1/2 times by 4 times by 3, and we get an answer of 6 centimeters squared. Okay, let's move on to the next shape. Your circle. Perimeter and area of a circle. First of all, the perimeter of a circle is called the circumference. There's the word, the circumference. It again is if we had just walked around the shape. The formula is 2 times pi times the radius. Now I'm going to stop there just to discuss this radius. The radius is from the center of the circle to the circumference. From the center of the circle to the outside of the circle. That is the radius. We're sometimes given the diameter of the circle. The diameter is the line that goes from the circumference to the circumference and passes through the center. Passes the center. Oops. So if I had to, let's try it with a different color and show you what, let's do that in orange. The circumference, the diameter would be from the end through the center to the other end. Now, I told you earlier that the radius was from the center to the end. So if I take that would be one radius and the other side would be a second radius. So what we end up seeing is that your diameter is equal to 2 radii. So if you're given an example or a sum where you've got the diameter and you need the radius for the formula, you're going to say your radius is your diameter divided by 2. So that's just something to bear in mind for when we start our calculations. Let's now try to do an example with the calculating the perimeter. And let's look at our example. In our example, we've got a radius of 5 meters. We want to find the circumference. So my formula for the circumference of the circle was 2 pi r, or that's 2 times pi times the radius. And let's substitute our value in. We've got that as 2 times pi times 5 meters. I want to stop there for a second and just discuss pi. Now, pi is a number on our calculator. We can actually, if we press in pi, we find pi on the calculator, and press equals, we can see that pi is 3,14159, etc., etc., etc. Read the question very carefully, because sometimes they just give you the formula and say find the circumference of the circle, and then you're going to use pi on your calculator. But there are other times that they'll say to you, use pi equals 3,14. Please read the question carefully and use the pi value that they've given you. It doesn't make a big difference to the calculation. Probably won't make a big difference to your marks, but it's easier to mark, and we're dealing with a rounding off error. Because if we use pi on the calculator, it carries all these decimal places. Whereas if you use pi equals 3,14, it has simplified the number. So just read the question carefully and use whatever it is that they give you. Let's go back to our question. And they haven't told us, so we're going to use pi on the calculator. So 2, and don't forget to put in your times, your multiplication signs, because you might get an error on your calculator if you don't. Depends on which calculator you use. So we're just going to get into the habit of using the multiplication sign, makes it easier. So 2 times pi, so I've got to shift and find pi, times my radius, which was 5, equals, and I get a solution of 10 pi, but press the button and it tells me that it's 31,42. We're going to round off, so let's go back to this and write in our answer, 31,42. And what were we dealing with? Meters. We've only got 1 meter. We're dealing with perimeter, and it's one-dimensional, so it's meters. Let's go back and look at the area. So, area of my circle, and I'm going to take away all these wonderful calculations we've done. The area of the circle, you will be given the formula is your pi times radius squared. Again, don't forget, you need to might need to calculate the radius, which is your diameter divided by 2, and we're looking for the area, that's the whole space, and it's 2-dimensional. So let's go do a calculation using the same example of 5 meters. A little bit more space here. My area, oops, I need a pen. My area is pi r squared, and I'm going to rewrite that as pi times my radius squared, just so that I remember to put in that multiplication sign, and then substitute. We had pi times 5 squared. I'm leaving out that meter because it sometimes confuses me. Let me explain. If I write it as pi times 5 meters squared, I sometimes think that that is squared, but in actual fact I need to square the number. So to avoid that complication, I'm going to leave the meter out. If you'd like to add the meter, then rather use a bracket so that you know you're multiplying the 5 is squared. Let's go to our calculators now. And we've got pi times 5 and squared equals 25 pi calculate it, 78,54. So let's go back to that, 78,54. And my unit, don't forget the unit, are meters squared. What's the next shape we have? No, we've done the shapes, and like I said to you earlier, most of your questions will be broken down into one of those shapes, so the formula you can use them. So let's look now at surface area and volume. We're only going to be dealing with 3 types of shape. We're going to deal with the rectangular prism, the cylinder, and the triangular prism. Right, so now we're dealing with 3 dimensions. Okay, let's look at our surface area. We've got our different shapes. So the first one we're going to look at is our length times our breadth. There's my length and there's my breadth, and I'm going to color in that part of the shape. That's going to give me the one side. So that is my length times my breadth. Let's try a different color. And now we're going to look at my length times my height. There's the length of my shape, and that's the height of the shape. So it is this top section that is length times height. And then lastly, here's a third color, and here's a different color. We're looking for our breadth times our height, which is my breadth there and the height, and that's that shape. So I'm looking with 3 different types of shapes. And that's why I've got 3 shapes in the formula. But I've also got this 2 in front. And what does this 2 actually mean? This little 2. If I take away these colors, make it all look pretty, take away the colors, it'll be easier to see. This length times breadth, which is this first one here, is exactly the same on the other side of the shape as the length times height, which is the top part of the shape, is the same at the base of the shape. And the height times the breadth, which is the side piece, is exactly the same on this side piece. Now, let me try to draw it into 3 dimensions this way, and that might help. So this shape here is the same as that shape there. I hope that helps. So our formula, and again, they will give you the formula. It's nice to be able to understand the formula. It makes it easier for you to actually work with the values. Let's do an example quickly with the surface area. Right, let's do an example. We'll be looking at our length is 4 meters, our breadth is 2 meters, and our height is 3 meters. Now, it probably will be easier for you to draw that, write those into the equation. Let's actually redraw this shape quickly. So we've got, here's a pen. Let's quickly redraw this here. It might be easier for us to add our values. So we've got a length of 4 meters. We've got a breadth of 2 meters, and we've got a height of 3 meters. And then substituting into our formula. So my surface area was 2 times my length, which is 4 meters, times my breadth of 2 meters. Where did that come from? 4 meters times 2 meters, plus the length times the height, and lastly the height times the breadth. And this is all times by 2. So I'm going to use double brackets. Let's get our calculator out. Right, so we've got 2 times. Open our bracket. Open a separate bracket for each one of the sides. So it was 4 times 2 plus, left out the close bracket, plus 4 times 3, close that bracket, plus, open the last bracket, 3 times 2, and close the big bracket, and we end up with an answer of 52. So our answer is, a pen, 52, and we're dealing with surface area, two-dimensional, 52 meters squared. Let's go back up and do the volume, which is actually a whole lot easier. As far as the calculation goes, our volume is just our length times breadth times height. So it is the length times the breadth times the height, and this gives me the everything inside this three-dimensional shape. It is basically the air inside the shape. So let's do an example. So we've now got, up a little bit, the same example. We'll use the same values. So my volume, I'm going to write out my formula, is length times breadth times height, and that is, substitute in 4 meters times by your 2 meters times 3 meters, and do that on our calculator if we need to. So it was 4 times 2 times 3, and we get an answer of 24. 24, we're dealing with volume, which is three-dimensional, so 24 meters cubed. And we can also see that we've actually multiplied meter by meter by meter, which gave me my meter cubed. Right, let's move on to our triangular prism. Triangular prism, it looks a little bit like a tent. First, let's look at our surface area. So, our surface area of our tent is 2 triangles. So, we've got a triangle here. That's one triangle, and we've got the second triangle there. So, the surface area is 2 triangles and 3 rectangles. Let's delete that and see if we can see the 3 rectangles. We've got one at the base that this tent is sitting on. One is this side here. One is that side there. One is this back side, and one is the base, like I said. So our surface area is 2 triangles. So we're going to use 2, and the formula for the area of a triangle, half the base times the height. Then we've got 3 rectangles. So it is literally the side of each of the triangles plus multiplied, by the height. That's going to give me the area of each rectangle. Now this side one here is actually the base. Let's try to do an example. Right, if we're dealing with a triangle that has a base of 6 meters and a height of 4 meters, we've got sides of 5 meters each and a height, that's the height of the shape, of 3 meters. Right, let's draw our shape to make it easier. We'll start off by drawing the triangle. Triangle has a base of 6 meters and it has a perpendicular height of 4 meters. So let's start with that part of the equation. So we've got 2 triangles, and the triangle for each, the formula for each triangle is half times the base, and the base was 6, times the perpendicular height, which was 4. That's that part of my equation, just the triangles. Now let's carry on drawing our shape, and we will see, whoops, right, our 3-dimensional shape. The height of the shape is 3 meters. That's my 3 meters. And each one of my rectangles is based on the sides of my triangle. So my first rectangle, I'm going to use the base. That's my side one. That was 6 meters times by the height of the shape, 3 meters. That's the one rectangle. We need another 2 rectangles. So this side we said was 5 meters. So the area is 5 meters times by 3 meters. And the last rectangle is this last side, which was also 5 meters. And then we've got all the formula that we need, and now all we need to do is put it onto our calculator. So I'm going to use the brackets exactly like that, because it makes it easier and I don't forget things. So my 2, let's put in a multiplication, 2 triangles. Formula, half, whoops, times the base times the height. Then I'm going to add the first rectangle, 6 times 3, then the second rectangle, which was 5 times 3, and the third rectangle. Close that bracket, press equal, and we get 72. So let's go back to there. 72, and we're dealing with surface area, 2-dimensional, meters squared. Right, let's try our volume. Okay, let's get rid of that. When calculating a volume of a shape that you don't necessarily know, and it's not as easy as our length times breadth times height, we're dealing with a triangle, I like to think of the shape as what is my common shape throughout this prism. My common shape throughout the prism is actually my triangle. If I had to cut this prism anywhere along that shape, I will still end up with a triangle. So volume can be thought of as your common side times the height of the shape. So my common side, what is the formula for the common side? It is my area of my triangle. There you can see in the volume formula that's the area of a triangle. So I'm going to be dealing with half the base times the perpendicular height of the triangle, and then I'm going to multiply it by the height of the prism, and that will give you the volume. So let's go back and do an example using the same formula we had earlier. So my volume is the formula for my triangle, half times the base, which was 6 meters, times the perpendicular height of the triangle, which was 4 meters, and then we're going to times that shape by the height of the prism, and in this case it was 3 meters. All we need to do now is substitute that into our calculator. Use the fraction button. Formula for the triangle, half the base times the height times the height of the shape, and we end up with 36. So let's go back to writing our answer. A little bit more space here. Right, it's equal to 36. We're dealing with volume. What was volume? 3-dimensional. So it is 36 meters cubed. Again, you can see we multiplied meters by meters by meters. Please don't forget your units. They're very, very important. Right, next shape. And again, we're going to start with the surface area. And this time we're dealing with the cylinder. So our cylinder has a radius that is of the circle. So if I had to redraw that circle, you can see it looks like that. And then my height of my cylinder. Surface area. We have 2 circles. There's the circle here and the circle at the base there. There are 2 circles. So my formula for the area of a circle was pi r squared, and I've got 2 of those, so the surface area starts off with 2 times pi times radius squared. Then we're going to take this part of the cylinder, this part here, and if I had to unfold it, I would basically end up with a rectangle. So if I had to look at kind of a net, let's draw this rectangle a little bit bigger here. If I had to look at a net of this shape, I would have a rectangle and my two circles. Should be the same size. This part of the rectangle, this part of the rectangle here, let's try a different color, is actually going to go around the circle. It is my circumference of the circle. And what was the formula for the circumference of the circle? It was 2 pi r. And then this part of the rectangle is my height of my cylinder. Can we all see that? So if I want to work out the area of this rectangle, I've basically got my length times breadth. But my length in this case was very special. It was the circumference of the circle, which is 2 times pi times r. And then my breadth was my height. That is how we derive the surface area of the cylinder. Be careful the way they sometimes give you this formula. They will sometimes say use the surface area, let's just write it here, is equal to, and they will take out common factors. Now I know if I say factors that kind of scares you, but don't be scared. You know this formula. You will be given the formula and you just need to deal with the formula that you're given. So we can take out a 2. That doesn't look like a 2. We can take out a 2. We can take out a pi, which is common. We can take out a radius, which is common. And what are we left with? We're left with the radius plus the height of the shape. So you might see that formula. That formula and that formula are the exact same formula. Substitute your values into what you are given and the formula that you're given. Let's try to do an example. In fact, I'll do the example with both formulas so you can see there's nothing to be scared of. So, if my radius is 3 meters and my height of my cylinder is 4 meters. My surface area, I'm going to write out my formula now. So I've got 2 pi r squared. That's 2 circles plus my perimeter of my circle times the height of my shape. Let's do that underneath. We'll substitute in all the values. So I've got 2 times, oops, that doesn't look like a times. Let's try that again. 2 times pi. And again, remember, if they give you pi equals 3,14, then that's what you will substitute in now. Times the radius, which is 3 squared. Again, I'm leaving that meter out just so I don't get confused. Plus 2 times pi times my radius, which is 3, times my height of my cylinder, which is 4. All we do is substitute that into my calculator. So I've got 2 times pi times my radius squared plus, calculator can do it all for you, you don't have to do it in steps, 2 times pi times radius times the height, and we get an answer of 131,95. So let's go back and write that in. 131,95. And what are we dealing with? We're dealing with meters squared. Let's try the other formula. So let me write that formula in. Surface area, I said, was 2 pi r, and that was r plus h. That's the same formula that I gave you just now. 2 pi r, r plus h. So let's try substituting the values now. We've got 2 times pi times your radius, open brackets, your radius plus your height of your shape. Do that on our calculator. 2 times pi times radius, and open my bracket, 3 plus 4, and we end up with 131,95. Exactly the same answer. But don't be scared of a formula that you haven't necessarily seen before. Sometimes it's the same formula, and we teachers like to confuse matters and just change it around a little bit, but just follow the basic, simple method. Substitute in the values that you've been given. Right, let's look at our volume. Going back to volume. Remember just now I said to you, your volume you can think of your area of your common side times the height of the prism. So my common side in this case is my circle, because only if I cut the shape along the circle will I have the same shape. If I cut it anywhere else, I'm going to change my shape. So it is the area of the circle times the height. If we look at the formula, you'll see that it is the area of the circle, which is pi r squared, times the height of the shape. So let's do this example and go back to the question. We were looking at a radius of 3 and a height of 4. Let's just write that in quickly. My radius was 3 meters and my height was 4 meters. So now we're going to write our formula. Our volume is the area of the circle times the height of the shape. Substitute in my values. Our pi times 3 squared times 4. Use a calculator. Pi times 3 squared times 4. And we get that the volume of this cylinder was 113, I'm going to round that off, 1. Why 1? I'm going to write out the number so we can discuss the rounding off of it. So it was 113,097. 113,097. Let's just discuss the rounding off of this. Remember, 2 decimal places, unless you are told otherwise in the question. The beginning of your paper will always say round to 2 decimal places. Now, if I want to round this number, I'm going to draw a line after 2 decimal places to see whether I need to move it up or keep it the same. And then I'm looking at the 7. 7's bigger than 5, which means I'm going to increase the number before, increase this number before to a 10. So it's going to end up being 113,10. And what were we dealing with? Meters cubed. Now we don't need that 0. This 0 is actually meaningless. So it's 113,1 meters cubed. And don't forget your units. Right, now that we've done all the shapes, let's do some examples. So we're dealing with the question. Question 1 is dealing with netball. Now I want you to note that sometimes they're going to give you an example where you're not familiar with the sport or you're not familiar with the context that they're using. The concepts are the same, so don't let the fact that it's netball and you're a soccer player scare you. We can either learn about netball or we can just deal with the question. So we're dealing with netball. Might be a soccer player, but we're now dealing with netball. It's a game played between 2 teams with 7 players on each team. It's kind of easing you into the question and what netball is. The rectangular netball court is divided into 3 equal sections. Pretty sure that's going to be important, so I'm underlining it. With a center starting circle with a radius of 0,45 meters. As soon as the numbers, ding ding, bells should be going off. That is important. So I'm going to underline that. And what was that? 0,45 meters is my radius of my center circle. And 2 semicircles at each end marking out the goal shooting area with a radius of 4,9 meters. Again, ding ding numbers, 4,9 meters. So, and they give us a layout. So this is the netball court. The measurements on the diagram are not drawn to scale, so we know we're not dealing with scale drawings, which is great, and the measurements are all given in meters. So I have my length of my court is 30,5 meters. My breadth of my court, my width, 15,25 meters. Now I was given numbers in the question, and I'm going to actually write them into the diagram because it makes it so much easier for me to remember. So going back to those numbers that made dings in my head, I had a center circle with a radius of 0,45 meters. So that was 0,45 meters. And the radius from the center of the circle to the circumference. And then 2 semicircles at each ends, which I can clearly see in my diagram now, and the radius for them was 4,9 meters. Once I've got those written in, it's easier for me to remember, and I've kind of dealt with everything that's in the question. Let's go see what the questions actually ask. Your high school decides to build a grass netball court at their school and contacts Netball Incorporated to build the court. And I'm going to read through the whole question, and then I'm going to go one step at a time, and we're going to answer one step at a time. So calculate the area of the netball court in meters squared for 2 marks. The cost per goal net is 124.80. Calculate the cost of 2 goal nets. Guess we need 2 if we've got 2 teams playing. Lines will be painted on the netball court using a grass paint. Calculate the length of the lines that need to be painted in meters. And lastly, if it takes 2 workers 1 hour to paint the lines on the netball court, how many workers would be needed to complete the task in half the time? Those are our questions. So let's go do one at a time. Now, dealing with question A, I'm going to go back to my netball court. We're looking at the area. Calculate the area of the netball court in meters squared. Now, very useful tip for you to remember is always read the question carefully and work out what unit they want the answer in. Then do your conversions first. So we want our answer in meters squared. In this example, all the values were given in meters, so I don't have to worry about converting between centimeters and meters or millimeters and meters. But get into the habit of converting first into the answer that they want. So let's calculate the area of this netball court. The area, my formula, and you can go back to what the formulas were, and I'll give it to you again. The area of a rectangle was length times breadth. Get into the habit of also writing out the formula. You need to always bear in mind that you need to explain to your teacher, to your examiner, what you were thinking. Show every step of the working. Don't just give an answer. I'll discuss that with you in a second. So now we've got our formula. Let's substitute in. Our length of our netball court was 30,5 meters, and our breadth of our netball court was 15,25 meters. That step is worth 1 mark. If you don't show that step and you get the correct answer, you will probably get both marks. But if you get the wrong answer, you will get no marks. Whereas if you've made a mistake here in this step, you might not get that mark, but then your answer could be correct. So we call these method marks, and they're important to keep your method marks and continuous accuracy to show the examiner what's going on, what you were thinking. So get our calculator out, and we've got 30,5 meters times by 15,25, and our answer is 465,13 meters squared. So let's write that in. 465 0.13 meters squared. Don't forget your units, and that's where your second mark is. So you must show all working. Right, let's move on to B. So again, we've got our explanation, and we need to know the cost per goal is 124 Rand 80. Calculate the cost of 2 goals. We're going to need a goal on either side, so this is quite a simple calculation, and we're going to get these kind of questions even in amongst this area and volume and perimeter. We're going to get all of a sudden a simple calculation like this. So look out for those kind of easy marks. So our cost per goal is 124 Rand 80. This case, earlier I said to you that 0 didn't mean anything. In this case, my 0 means a lot. It's money. We have to have 2 decimal places. And I need 2 goals, so I'm going to multiply it by 2. Use a calculator again. 124 Rand 80 times 2, and we get an answer of 249 Rand 60. 249 Rand 60. Don't forget that it is 60, it is not ,6. And you must have your units. So it's not 249,6 Smarties or anything else. It is 249 Rand and 60 cents. Let's move on to the next part of the question. Lines will be painted on the netball court using grass paint. Calculate the length of the lines that need to be painted in meters. Firstly, again, look at what they want the answer in meters. Now, this kind of gives me a little bit of a clue, because they want the answer in meters. I know I'm dealing with one dimension. What am I dealing with? I'm dealing with perimeter. They want me to draw all these lines. So I'm going to go back to the question and fill in the values that I did earlier of the radius. So the center circle radius was 0,45, and the radius of the 2 semicircles at the end was 4,9 meters. And to fill in those values, because now I've got every value that I need. So the lines will be painted. I'm looking at every single line that is black on the screen at the moment. So let's break this down. I need 2 lengths. I'm actually going to color them as I go so that I can see I've got every line. So I need that length and that length. So let's start substituting that in. So we're basically looking for our lines. We've got 30,5 meters. And I can either times by 2 or add 30,5. So let's times by 2. I need 2 of those. Plus perimeter, we're adding. So we need these lines. How many lines have I got here? I've got 1, 2, 3, 4 of them. So the breadth of the field I need painted 4 times. So it was 15,25, and there were 4 of those. Then I need the center circle. The center circle, I'm looking for the circumference of the circle. So what's the formula for the circumference of the circle? It is 2 times pi times the radius. And I'm going to substitute in the radius. What did I say the radius was? 0,45. Okay, then we've got that circle. Plus, what else are we missing? We're missing our 2 semicircles. There's that one and that one. Now, 2 semicircles is the same as one big circle. I can actually do this calculation as one circle. So I'm going to, again, use the formula of 2 times pi times the radius. What was the radius in this case? It was 4,9 meters. And now I've got every line. I'm going to go back to my question and just double check that I have painted all the lines. Seems like it. They're all green. Therefore, I must have them all. And now we can just go and substitute that all into the calculator. So I'm going to use my brackets. It makes it easier for me to compartmentalize everything. So I've got 30,5. That was my length. There were 2 lengths. Plus, I've got my breadth. And there were 4 of those. Plus the center circle, which is 2 times my pi, times the radius, which was 0,45. Close that bracket. Plus the 2 semicircles, which I said I can use a circle formula. So 2 times pi times my radius, 4,9. Close that bracket and equals. And I get 155,62. So let's go back to this, write that in. 155,62. And what were we dealing with? Meters. 155,62 meters. Don't leave out that step. Don't ever just write the answer. Right, the last part of the question was dealing with time. If it takes 2 workers 1 hour to paint the lines on the netball court, how many workers would it be needed to complete the task in half the time? Again, got nothing to do with area and volume. One of those kind of different questions that come in every now and again in these kind of questions. So we've got 2 workers. Let's write out what we've got. We've got 2 workers who complete the task in 1 hour. Now we want to do this in half the time. So we're going to make that half an hour. We're going to take our 1 and divide by 2. So how many workers do we need to complete this in half the time? Now in this case, what we're dealing with is we're dealing with an indirect proportion. The more workers we have, the less time it's going to take to complete the task. So if we divide by 2 here, which is what we did here, we need to multiply by 2 that side. Because it's a direct proportion, as the one gets smaller, the other gets bigger. The less workers, the longer the time will take, and the more workers, the less the time. So as this is getting bigger, that's getting smaller. That's what I mean by indirect proportion. So our calculation is 2 times 2, which basically means it'll take 4 workers half the time to complete the court. Right, now let's look on to the next question and let's see what this question is all about. So question 2 says, Mr. and Mrs. Microrna would like to make a donation to help upgrade the local sports field. The sketch below shows a plan of the field. The measurements on the diagram, again, not drawn to scale, are in meters. So that's an important fact to know. Right, the sports field is made up of a rectangular grass soccer field. We're back to soccer. So now, for all those girls that don't play soccer, don't be scared by this fact. So our soccer field is 80 meters by 95 meters. Numbers, ringing bells, we're going to need those. And 2 semicircular, also an important fact to know, semicircular is half a circle, seating areas of radius 47,5 meters. And 2 rectangular paved areas where there's a width of 5 meters. The paved areas separate the seating areas from the soccer field. So let's look at our sketch and see what we've got. Our soccer field, which was 80 meters by 95 meters. I'm going to pull in that value. we've got a paved area of width 5 meters. They've actually given it to you on the diagram. And then our semicircular seating areas, so half a circle, and the radius on that is 47,5 meters. Actually been given to you as well. Now let's see what the questions say. So, part A says, the Micrornas donate 3,000 Rand to buy fertilizer for the soccer field. So I guess we're going to be dealing with fertilizer in the soccer field. So, first part of the question says, calculate the area of the soccer field. So, let's do that first. The area is our length times breadth. Going back to our diagram, the length of the soccer field was 80 meters and the breadth was 95 meters. So we can substitute in those values, 80 meters times by 95 meters. And now let's use our calculator to calculate the area. 80 meters times 95, and we get 7,600 or 7,600. And our unit is meters squared. Now this question didn't ask us it didn't specify which unit to give our answers in. So in that case, any unit would make sense, but we're dealing with meters, so let's not change it, let's not complicate things, and let's give our answer in meters squared. Second part of the question says, calculate how many bags of fertilizer can be bought with this donation if one bag of fertilizer costs 49 Rand. Again, it's got nothing to do with our area, but first we've got to work out how much money did they spend. They donated, they made a donation, it was somewhere up here, let's find that number. They made a donation of, okay, good question, where's the, like to donate to the soccer field? No, it was in the question. They donated 3,000 Rand to buy fertilizer. So, we've got our amount of money, so this is the second part of the question, was 3,000 Rand. We want to know how many bags of fertilizer they can buy if one bag costs 49 Rand. So we're going to take the amount of money that they donated and divide it by 49 Rand. And that's going to give us how many bags of fertilizer can be bought. So we need our calculator. So 3,000 divided by 49 Rand each, and we get an answer of 61,22. So let's write that in. 61,22 bags. But now, can we go and buy 0.22 bag of fertilizer? No, we can't. We need to buy whole bags. Can we buy 62 bags? We don't have enough money for 62 bags. So we're going to, in this case, round down, and we're going to say we can buy 61 bags of fertilizer. Now again, I want you to show all your working. Show this step. Don't just go to the answer of 61 bags. Show every step so that you can explain to the examiner, your teacher, that you know exactly what is going on and that you understand the constraints. And in this case, what were our constraints? The amount of money that we had. We can't buy 62 bags. We don't have enough money. So we round down to 61 bags. Right, let's see what the next part of the question says. The Micrornas would also like to donate money to fence the perimeter of the sports field. So the perimeter is the entire outside of the sports field. They want to fence it. So first part's going to be determine the length of A to D. So that is the distance between the two seating areas. So we want the distance of A to D. So how are we going to calculate that? It is my paved section. So imagine I was standing at A and I walked all the way to D. How long is that distance? That's that part of the perimeter. So it is basically my paved area. I'm going to actually do this here. It is my 5 meters plus the length of the soccer field, which was 80 meters, plus another paved section. And now I don't know if we need a calculator, but if we do, well, let's do it on our calculator. 5, not times, plus 80 meters for the field, plus 5 gives me 90 meters. So that is 90 meters. I'm sure I'm going to need that calculation later on in the question. Now we want to determine the length of the curved part of the seating area DEF. So let's go back to my seating area. What is that? It is, let's use a different color so we can see the difference. DEF is that curved part. What do we know about the seating area? We know that the seating area is a semicircle. It told us here, the seating area was a semicircle, half a circle. We know the radius of that seating area was 47,5. So using those facts, we can do the calculation. Let's do the calculation here. We're looking for the circumference of the circle, and the formula for the circumference of the circle is 2 times pi times the radius. Let's substitute in the values. 2 times by pi times by the radius, which was 47. I'm going to go back up to just check that. 47,5. 47,5. But now there's a little bit of a problem here. That is the circumference of an entire circle. And what do I have? What is this part of the circle? It is half a circle. So how am I going to deal with that? Well, I'm going to take my formula. I'm going to basically divide it by 2. And what ends up happening is my 2's actually cancel. So on my calculator, I can just type in that it is pi times the radius. And let's do that on the calculator. And we see that the area, the circumference of that seating area was pi times the radius. And it is 149,23. 149,23 what? 149,23 meters. One dimension. We're only dealing with perimeter. Okay, and have we answered the question? Let's go back and just check. It says determine the length of the curved part of the seating area DEF. I've calculated that area. I'm actually going to fill in that value, 149,23. To fill in that value, 149,23. I think it's going to help me in a moment. And this pink section, let's fill in that value, was 90 meters. Right, let's move on to the third part of the question. It now says determine the total perimeter of the sports field. So when we go back to our question, back to our diagram, what are we looking at? We're looking at a pink. If I just start at A and I'm walking right around till I get back to A. I've got a pink section, an orange, which I've got those values. Then from F to I is the same length as A to D. So I've got a 90 meters there. And let's go back to orange. From I back to A, going around that part, is the same as D to F. So that is 149,23. So what do I need to do? I can either take those two and multiply by 2, or can literally say, well, let's start at A. Let's do that. Let's do that. So my total, that was 1, 2, 3. My total perimeter was the pink part. Let's use the pink pen. Was 90 meters. Plus I had the orange part, which was 149,23. Make that a bit bigger. Plus a pink part, 90 meters, and plus an orange part, 149,23. So that gives me my total area. So I could have said that times 2, but I can write it out. It gives me the same answer. So let's do this all. I could have said it was my pink 90 meters plus my orange times by 2 because they doubled. So let's now plug that into our calculator. So we had pink part plus the orange part. No, we don't have a decimal place. 0.23 plus the pink part plus the orange part. And I get a total of 478,46. And what's my answer? Was 478,46 meters. Remember, one dimension. We've only just walked around the shape. We don't have area or volume. We've got perimeter, and that is my final answer. Have I answered the question? Let's go back and just double check. The question said, determine the total perimeter of the sports field. I have done that. So let's move on to the next part of the question. Right. Again, we've got Mr. Microrna, and now we've calculated the perimeter. And this very often happens. I'm going to read the question and then explain what happens. The total perimeter of the sports field is 478,46. What calculation did we get? We got our answer of 478,46. So very often in the next part of the question, they actually give you the answer that you were looking for. So it kind of gives you this little bit of a check. Am I doing it correctly? But please, if you don't get the exact same question, don't stress. You will still get method marks for the method that you've used. So don't let this throw you totally if they now give you an answer that's not the same. So this question says the total perimeter of the sports field is 478,46 meters, and we need 4 gates, each of 2 meters wide, that are put into the fence. Calculate how much fencing will be needed. So let's think about it like this. I have my sports field. I'm going to draw my sports field. And that I know is 478,46 meters. I need to put in 4 gates. So I'm going to put in 4 gates. I'm going to delete in each place. The size of the gate is 2 meters. So the rest of the field needs to be fenced with fencing. So how much fencing will I need? I'm basically going to need my 478,46 meters, and I'm going to minus the place where I've got gates. How many gates do I have? I've got 4 gates, and each gate is 2 meters wide. So I'm going to have my 478 meters, 46 meters, and I'm going to minus 8 meters. Which is going to give me the remainder of the orange lines that are fencing. So do we need a calculator to do this? I don't think so. But if you do, go back to your calculator and we end up with 470,46 meters. Remember 2 decimal places, and remember we can't change it. We can't say 470 meters because then I'm going to have a 46 centimeter gap somewhere, and I don't want any gaps, otherwise people are going to be getting through the fencing. So that takes me to my final answer. Go back to read the question again. Have I answered it correctly? It gives me the total perimeter. Calculate how much fencing will be needed. Well, I know how much fencing I will be needing, so I've answered the question. Right, let's move on to the next question. Right, question 3. Nao is employed at a business that designs and makes packaging for small balls, fruit juice and biscuits. One of the first tasks that Nao is given is to design packaging for squash balls. He's going to be designing packaging for squash balls. The pictures below show the dimensions of a rectangular box and a cylindrical container that Nao is considering using for packaging the squash balls. So let's quickly look at our different dimensions. We've got a cylinder which has a height of 165 millimeters and it has a radius of 22 millimeters. And we have a rectangular prism whose length is 165 millimeters and a square on the end. Our common side here is a square of 42 millimeters by 42 millimeters. So those are the two boxes that we are considering. Now let's read the question. If a squash ball has a diameter, what was a diameter? A diameter was from one side of the circle to the other side of the circle, passing through the center. Has a diameter of 40 millimeters, how many squash balls is a box or a container designed to hold? Now, my box or my container has the same length. So we need to do this calculation once. So we're going to take our length of both shapes are the same, 165 millimeters. Our squash balls are 40 millimeters in diameter, which basically means that it is 40 millimeters right through. So we only need 40 millimeters. We're going to divide 165 by 40 millimeters. And we're going to put that onto our calculator. 165 divided by 40. And we get an answer of 4,125. Okay, or 4,13. So let's go back to here. 4,13. What is that answer? 4,13 balls. But I can't have a 0.13 of a ball. So what does my answer mean? I can only fit in 4 squash balls. And we've got a little bit extra space in the box. And that's make it easier for us to actually put the squash balls in. Let's go see what the next question says. Right, we know about Neo, we know about the thing. So, a net is a two-dimensional picture of what an object looks like before it is folded into this 3D. So if we had to take these shapes and unfold them into 2-dimension, that would be a net. They want us to draw a rough net for the rectangular box and for the cylindrical container. The nets do not have to be drawn to scale. The dimensions of the various parts of the box and container must be filled in on the net. So let's start with our cylinder. What is our cylinder made up of? It's made up of 2 circles, one there and one there, so we can draw those. So our cylinder is a circle, and in between the circle, I'm just going to draw the one for now, we've got our rectangle. So we've got a rectangle and we've got our second circle. That is our rough diagram of the cylinder. But they want a dimension. So what dimensions do we have? We know that the radius of the circle is 21 millimeters and the height of the shape is 165 millimeters. So we're going to fill in our values. Our radius here was 21 millimeters and our height 165 millimeters. And we can fill in the radius here as well. Now we've got all the values that we need in order to get our 2 marks. Let's go back to our rectangular prism. And what have we got? We've got 2 squares and 4 rectangles. The rectangles all have the same shape. So we're going to draw that as 2 squares. I'm going to only draw 1 square for now, and 4 rectangles, all with the same width. And my other square. Now we need to fill in our values. What values do we have? We've got our length and breadth of our square is 42 millimeters. Each one of these has to be 42 millimeters, and we can fill it in at the bottom as well. And lastly, our height of our shape was 165 millimeters. And that's our net. That is, if we had to fold this back up, we would end up with the shape that we had on top. So let's move on to the next part of the question. Right. We need to calculate how much cardboard Neo needs to build the rectangular box. So, what are we looking for? How much cardboard does he need? We're looking at the surface area. And the surface area of our rectangle, I'm going to give you the formula again, was 2 times the length times the breadth plus the length times the height plus the breadth times the height. Now you will probably be given this formula in an exam type question, so don't stress about the formulas. Now let's substitute in the values that we know. We know that our length, and in fact I'm going to write it on the side here. Our length is 165, that's an L, and we've got a breadth and a height. So I'm going to write out those values just on the side here. The length I said was 165 millimeters, the breadth was 42 millimeters, and the height was 42 millimeters. This way it's easier to not get confused, because now I'm just going to be substituting these values into the equation. So my equation will be 2 times the length of 165 times the breadth of 42 plus the length 165 times the height of 42 plus the breadth, which was 42, times the height, which was 42. And then I've got all the values, I haven't made any mistakes, and I can put that into my calculator. So I've got 2, and open my brackets, 165 times 42 plus 165 times 42 plus 42 times 42, close that bracket, and I end up with 31,248. So let's write that number in. 31,000, I can't remember what that was, 248. And what are those 31,248? What were we dealing with? Millimeters squared. They did not specify in the question what they wanted the answer to be in, so we can leave it in millimeters squared. Right, then next part of the question, D says calculate how much cardboard he needs to build the cylindrical container. So let's go, that was question D. My cylindrical container, in this case my formula, again I'm looking for my surface area. So my surface area for a cylinder is 2 pi r squared, that's my 2 circles, plus the perimeter times the height of the shape. Again, I'm going to go back to the question just to check what were the dimensions that I've been given. I've been given the radius is 21 millimeters and my length is 165 millimeters. Well, that's the height in this case. So my radius here was 21 millimeters and my height was 165 millimeters. Just makes it easier for me to not get it wrong. So substitute that into the formula. So my surface area is 2 times my pi times 21 squared. I'm leaving out the millimeters again like I did earlier, so I don't get confused and I know I need to square 21 plus 2 times pi times 21 times the height of my shape. Let's get our calculator out. And we got 2 times pi times 21 squared plus 2 times pi times the radius times the height of the shape and we get an answer of 24,542, 12. So my surface area is 24,542, 12. What were we dealing with? Surface area, millimeters squared. Don't forget your units and don't forget the correct units. Have we answered the question? Let's go back and check. Calculate how much cardboard he needs to build the cylindrical container. We've answered the question. Again, they didn't give us which units they wanted the answer in. They didn't ask for meters, so we can give them the answer in millimeters squared. Let's move on to the next part. Based on your calculations above, would it be cheaper for Nail to package the squash balls in a cylindrical container or a rectangular box? And explain your answer. Now, what are we dealing with here? We've dealt with surface area and we've got our two answers. So let's actually write out our two answers. So we had our cylinder. Let's go back and check. What was that? Our cylinder was 24,542. So let's write that in. 24,542, 12 millimeters squared. And our rectangular prism, we can go back and check, was 31,248. 248 millimeters squared. Now we're comparing millimeters squared to millimeters squared, so we can kind of ignore that. And we want to know which is cheaper. So what's going to be cheaper? It's going to be cheaper if we use less cardboard. Which one has less cardboard? Our cylinder has less cardboard. So which package should he use? He should use the cylinder and explain your answer. And you can give kind of any answer that makes sense, but it uses less cardboard and therefore will be cheaper. Now you can make your own decision as to which package he should use. So the question said, based on your calculations above, would it be cheaper? No, we need to look at cheaper. And which is going to be cheaper? With the less cardboard. So we need to use the cylinder. All right, let's go see what the next part of the question says. If you walk around the shops, you will notice that most squash ball manufacturers package their squash balls in rectangular boxes, even though we've just calculated that cylinder is cheaper. So most golf balls and tennis ball manufacturers also use rectangular boxes. Why do you think this is the case? Now we need to put on our thinking hats and think about an answer. And kind of like any answer that you come up with, as long as you can justify it and give a reason, would be a valid answer. So try to think out the box. But now, tells me that it's rectangular boxes. And when I walk around the shops, I think about space. What takes up less space? What's easier to package? Easier to package into boxes, easier to package on the shelves. And I think that the reason for rectangular boxes is probably because of space in boxes. It's maybe easier. It's easier to package. It's easier to place on the shelves. It's less likely to roll off, so it can't roll off the shelf. And maybe those are just some of the reasons why you could use a rectangular box rather than a cylinder, but I'm sure if you think about it, you could come up with lots of your own ideas and your own solutions to that. Right, and that takes us to the end of our examples that I've got for you today. So I hope that I've helped you with 2-dimension and 3-dimension. Please remember the few key facts. Don't forget to add your units. Don't forget to read the question carefully and make sure that you've answered the question like they've given it to you. don't forget to convert to the unit they want the answer in first, and just take it slow. You're given the formula, substitute in the formula, and I know that you can do this. So good luck with it, and hope to see you soon.